In 1989, Ferrari mechanics laughed at Honda for daring to build a supercar. One headline dismissed it as a Civic trying to be a Ferrari. Then Ayrton Senna pushed the prototype to its limit at Suzuka, and the feedback he delivered forced Maranello into the most humiliating redesign in its history. To understand how, you need to know what Honda was building behind closed doors. In the late 1980s, the idea of a Japanese company challenging Ferrari's supremacy in the supercar world was met with open scorn. Maranello's corridors echoed with jokes about Honda's ambitions. A 1989 memo circulated among Ferrari engineers warned, with a hint of mockery, that Honda's thin aluminum monocoque will crack under real-world stress. The sentiment was clear. The NSX was dismissed as a toy, a fleeting experiment from a company best known for reliable sedans. The European automotive press followed suit. Headlines from the era painted Honda's effort as a punchline. Road and Track ran a headline calling it Japanese imitation, Honda's attempt at a supercar. Motor Trend's October 1989 issue sneered with the headline, Civic trying to be a Ferrari. The message was repeated across magazine columns and workshop floors. And Honda was overreaching, and the NSX was destined to fail. Inside Ferrari's own workshops, mechanics reportedly referred to the project as a Ferrari-style toy built by a company that usually makes reliable commuters. The notion that a mass-market manufacturer could match, let alone threaten, the prestige of Maranello was unthinkable. Engineers in Maranello dismissed the all-aluminum construction as a gimmick, predicting it would never withstand the demands of high-speed driving. This atmosphere of derision set the stakes for what followed. Honda was not merely building a car, they were entering a world where reputation was everything, and the gatekeepers were eager to see them stumble. The skepticism was not quiet or polite, it was loud, public, and in the eyes of the establishment, entirely justified. Only something extraordinary would force these critics to reconsider. Honda's engineering team took a path that no other supercar manufacturer had dared to follow. Instead of relying on steel space frames or hybrid steel and aluminum structures, they committed to a full aluminum monocoque, a decision that drew skepticism from every corner of the European automotive world. The goal was to create a chassis that was not only lighter than its rivals, but also stiffer, setting a new standard for dynamic precision. To achieve this, Honda's engineers turned to advanced tools, running structural simulations on a Cray 2 supercomputer. Every major load path was mapped and optimized before a single panel was pressed. The target was ambitious, a chassis weight of just over 200 kilograms and torsional stiffness that would surpass anything in the segment. The numbers they aimed for, over 20,000 Newton-meters per degree, were unprecedented for a road car at the time. But the technical challenge was not just in the design. Mass-producing an aluminum monocoque meant inventing new manufacturing techniques. Honda pioneered the use of friction stir welding on critical joints, a process that fused large extruded sections with minimal distortion. Quality control protocols were set to an exacting standard. Panel gaps were measured to within 0.8 millimeters, a figure that rivaled the best in the industry and far exceeded typical supercar tolerances of the era. Each step in production was monitored and logged, with engineers constantly refining the process to ensure consistency across every chassis. The result was a structure that combined lightness, strength, and repeatable quality, attributes that would soon be put to the test, both on the track and in the hands of the world's most demanding drivers. When the Honda NSX finally faced its rivals on neutral ground, the numbers told a story that mockery could not erase. In Car and Driver's 1990 five-way sports car shootout, impartial test drivers pushed each car to its limit on the skid pad. The NSX recorded 0.96 g of lateral acceleration, outgripping the Ferrari 348, which managed only 0.89 g. Slalom times echoed the result. The NSX threaded through at 71 miles miles per hour, while the 348 lagged at 66 miles per hour. The data sheets, compiled by seasoned testers, revealed a pattern where the Ferrari's steering was described as nervous and prone to snap oversteer. The NSX delivered neutral handling and predictable grip. Build quality metrics drove the point home. Panel gaps on the Honda averaged just 0.8 millimeters, a figure that rivaled the best mass-produced sedans, and stood in stark contrast to the Ferrari's average of 1.3 millimeters. Reviewers praised the NSX's climate control, quiet cabin, and visibility, qualities that had never before been associated with a mid-engine exotic. The Ferrari's air conditioning, by comparison, was unreliable, and its cabin noise made daily driving a chore. The data left little room for old assumptions. The NSX was not just competitive, it was objectively superior in ways that could be measured, audited, and repeated. The mystique of Maranello began to buckle under the weight of empirical evidence. Ayrton Senna arrived at Suzuka in early 1989. Stepping out of the pit lane in loafers and casual clothes, Honda's engineers handed him the keys to their prototype, eager for validation. Instead, Senna's verdict landed like a thunderclap. He said the chassis felt fragile. Those two words, recorded in Honda's test logs, cut through months of technical pride. Senna wasn't just any test driver, he was the reigning Formula One champion, with an instinct for weakness that no simulation could predict. The engineering team returned to their workstations, scrutinizing every weld and extrusion. They reinforced the side rails, added bulkhead stiffeners, and recalculated every load path. The result was a 50% increase in torsional rigidity, raising the chassis stiffness from roughly 14,000 to 21,000 Newton-meters per degree. The weight penalty was minimal, just 15 kilograms, but the transformation in handling was profound. The NSX now offered a level of composure and feedback that no rival could match. Senna's influence didn't end with technical drawings. According to widespread reports, he later lapped Suzuka in that same NSX, wearing loafers, no helmet, and driving with the same precision he brought to a Grand Prix. The story spread quickly, fueling a new narrative. The NSX was not only engineered for the track, but now bore the fingerprints of the world's greatest driver. For Ferrari, the ridicule had turned to a quiet reckoning. The outsider had forced a fundamental change in what a supercar could be. Luca di Montezemolo did not waste time in the aftermath of the NSX's arrival. The embarrassment inside Maranello was acute. Road tests and customer feedback left no doubt that Ferrari's 348 had been outclassed. Montezemolo's response was direct. He ordered the F355 project to accelerate, demanding sweeping changes to restore Ferrari's reputation. Engineers were given a mandate to increase chassis rigidity by 30%, a figure drawn from internal benchmarks and public comparisons with Honda's breakthrough. The new F355's aluminum silicon alloy chassis delivered on that promise, addressing the flex and unpredictable handling that haunted the 348. Suspension geometry was revised, and an electronic adaptive damping system was introduced to tame the harsh ride. The result was a car that posted a 0 to 60 miles per hour time of 4.7 seconds, over half a second faster than the 348. Montezemolo's own words, recalled by senior staff, made the stakes clear. Ferrari would not be outdone by a company it had once dismissed as an upstart. Every decision on the F355 program reflected that urgency, from the widened track to the obsessive focus on build quality. The days of dismissing Japanese engineering as a passing threat were over. Gordon Murray, the architect behind the McLaren F1, studied the NSX with the eye of a man searching for a new standard. In interviews, he described the Honda as the only supercar he'd ever driven that felt truly usable, balanced, precise, and free of the quirks that plagued its European rivals. Murray's own words, recorded in a Hot Cars feature, leave no doubt. The NSX was our benchmark. I drove all the contemporary supercars, and the NSX was the only one to which I returned time and again. For the McLaren F1, Murray set a target that would have been unthinkable just a few years earlier, 30,000 Newton-meters per degree of torsional stiffness. That figure, drawn directly from the NSX's own chassis data, became the minimum for the F1's carbon fiber monocoque. Murray credited the NSX's driver-focused ergonomics and tactile steering for shaping his vision of what a supercar should deliver, not just on the track, but on real roads and in daily life. The influence spread quickly. Engineers at other marques, from Porsche to Lotus, began referencing the NSX when discussing cockpit layout, serviceability, and ride comfort. One Ferrari mechanic, years after dismissing the NSX as a toy, admitted in a 2024 interview that the car showed us what we'd been ignoring, how a supercar should actually feel to drive. The old hierarchy had been upended. The NSX was no longer an outsider. It was the benchmark everyone measured against. Today, every supercar chases the balance, precision, and reliability the NSX first demanded. What began as mockery ended as a reckoning. Engineering, not heritage, sets the standard now. The lesson is clear. Arrogance yields, eventually, to proof. Nothing silences doubt like performance delivered. Share your thoughts below.